Hello everyone. In this video we're going to be solving a radical equation, a very radical equation. I'll tell you why. We have the fifth root of 5 plus x plus the cube root of 4 minus x equals 3, and we're going to be solving for x values. Why did I call this very radical? Because we have the fifth root and the third root. How bad this can get, right? So let's go ahead and look at this from a traditional perspective. Now, when you have a radical equation, let's say you had the sum of two cube roots or the sum of two square roots. How would you solve it? You would probably square both sides, right? Maybe you would do it slightly differently. Like let's just make up an equation, okay? I don't even know if this has a solution, but I'll just might kind of make it up. Now, if you had an equation like this, you would either square both sides or you would subtract one of these because that kind of makes more sense. You don't want to multiply these together. Maybe just isolate one of the radicals and write it like this first, and then square both sides. That'll probably be better, right? You'll get to the result faster, I think. And then you would, of course, isolate the resulting radical from here and square one more time, and then just solve for x. And of course, at the end, you need to check for extraneous solutions. What does that mean? Sometimes you find solutions, but they don't satisfy the original equation because you squared both sides, and sometimes a positive number can equal a negative number, but when you square them, what am I trying to say? Okay, sorry, I'm making it too confusing. So this is what I'm trying to say. A squared equals b squared does not necessarily mean a equals b, because it could also be that a equals negative b, okay? So that's why you gotta check if you're squaring or raising to an even power on both sides. So from that perspective, if you look at this equation, and we can call that first method, and it's going to look like this. I will be isolating one of the radicals. So which one should I do though? It's kind of hard to tell, right? We have the fifth root and the cube root. Maybe the fifth root kind of makes things more complicated. So let's isolate that and put the cube root on the right-hand side. Subtract that from both sides. And then of course we have the fifth root on the left. That's why we're going to go ahead and raise both sides to the fifth power, because our goal is to get rid of all the radicals, right? When we do this, it's good on the left-hand side, but on the right-hand side, you're gonna get something super messy. You know why? Because this is from the binomial theorem. You kind of need to think about a minus b to the fifth power, and if you just start writing it, it's gonna look like this. A to the fifth power, and then you're gonna have minus 5 choose 1, which is 5, a to the fourth power b, and you're gonna have 1, 5, 10, 10, 5, 1. Okay, so the next number is just going to be 10, which is a cubed b squared. And you're going to have 10 again. Notice the symmetry. These two powers kind of switch around. And then plus 5ab to the fourth. Again, these two switch around. Minus b to the fifth power. Now imagine this is your b, and you kind of have to raise it to different powers. It's going to be very hectic, right? I mean, it's going to be crazy. You're going to get more and more radicals. So this is going to get worse and worse, right? So you don't want to do that, do you? I don't think there's a solution through this method, even though there might be at some point. Or maybe, what would happen if we kept both of these radicals on the same side? I'm just thinking. And maybe we can raise both sides to the 15th power, because that is the least common multiple of 3 and 5. That might be helpful. But again, things are going to get super messy, and I don't even know if there's a way to clean it up. If you do know, let me know. Maybe one day, or maybe Monday, who knows, right? We're going to ask ChatGPT or something like that if there's a way to solve it. I don't think I'm going to try to do that. Anyways, but you get the idea, right? This gets real messy. So we're not going to do it. What are we going to do then? We're going to do something else. And that is what makes this problem awesome. I think that's what makes this problem beautiful, because there's a really cool way to approach these problems. Of course, we're talking about some special scenarios. Even if there wasn't a special scenario here, I think it would be much, much better than trying to raise both sides to the fifth or the third power. Of course, we could also isolate the cube root and raise both sides to the third power. That would probably give us something similarly messy, okay? Now, what is that magical or mathematical method, right? So here's how it works. We're going to use a super awesome method, which I use all the time, almost all the time, right? And you probably know that if you've been following this channel for a while. Hopefully you are, and continue to do that, I have another channel, by the way, called aplusbi, which focuses on complex numbers. Also, make sure to check it out and let me know what you think. If you're new to complex numbers, go ahead and check out the lecture videos. Okay, I published 2 videos on aplusbi and 2 videos on SyberMath, which is my very first channel. Anyways, so now here's what we're going to do. We're going to use, do you know that method, what it's called? Substitution. Starts with an S, right? So here's what we're going to do. We're going to call this A, and we're going to call this B. Awesome, right? Now you're like, what the heck? Like, why do you go from a single variable to 2 variables? Because it makes things easier. So now this turns into A plus B is equal to 3. Simple enough? That's not the end of the story, though. Here's where the story starts. We said that, okay, the 5th root of 5 plus x equals A. So we can now, in a much better way, raise both sides to the 5th power. That'll give us 5 plus x equals A to the 5th. And from here, similarly, we can safely say that 4 minus x is equal to b to the 3rd power. If we just raise both sides to the 3rd power after naming that b. Make sense? Great. Now, we have these 2 things along with this, so I think we're in good shape. But we can make it even better. How? We can do the following. Look, we can take these 2 equations and add them. Ta-da-da-da. This is where the math magic happens. We get rid of x. And that's the whole goal, because we want to go from the x world to the AB world. Yes, there are 2 variables, but we get a system, which is a lot easier because guess what? There are no radicals. Who likes radicals anyways, right? I mean, I guess nobody, right? So from here we get the following. A to the 5th plus b to the 3rd is equal to 9. 5 plus 4. Easy, right? Let's go ahead and bring that over here. And now take a good look at the system. Just enjoy. Take a look, right? And we can make it even better because substitution is awesome. You can continue to use it. Let's use it one more time. Isolate b from here and write it as 3 minus a. Now go ahead and sub this into this one. Ta-da-da-da. We could also do the opposite, but guess what? If you isolated b and wrote it as 3 minus a, you would have to raise it to the 5th power. I don't think you want to do that. This is a little easier. So it's always good to stay on the lazy side. And that's what I'm trying to do, be lazy, because that's how you can get better, more efficient results. Okay? That doesn't mean we're not going to do the work. It just means we're trying to take the easy route. Now, here's how it goes from here. A to the 5th power plus b to the 3rd, which is 3 minus a to the 3rd power equals 9. Look at that. We got a radical equation. It was really, really radical, too radical maybe for us. And then solving it by, raising both sides to some powers would be super messy, probably impossible to solve. But now we ended up with a beautiful polynomial equation. Don't you love polynomials? I mean, better than radicals, I hope. Anyways, now, let's go ahead and expand this. Now the way I cube these kinds of things is usually I will cube the first term minus the second term, and then I will put a minus 3xy term, which is going to give me 9a, and then I'll have the x minus y again. It's kind of weird, I know, but you can also use the binomial theorem if you don't like this. I'm hoping that you'll like this. Now 27 minus a cubed minus 27a plus 9a squared equals 9. Beautiful. Now, let's go ahead and rearrange these terms, a to the 5th, and then we're going to bring the 3rd power next, and then plus 9a squared. And then I have the minus 27a. And then I will bring the 9 over, minus 9. 27 minus 9 is equal to positive 18. A lot of 9s, a lot of multiples of 9s, right? Great. Maybe 9 is a solution, who knows, right? So the next thing, we're going to try to find a solution for a. And I'm hoping that a is an integer. Why? Because if not, it could be a rational number. But guess what? Since this is monic, it needs to be a factor of 18. So it's probably going to be an integer if you're looking for good solutions. If the answer is irrational, we can't solve it because there's no quintic formula. I know some people are going to be upset like, oh, we can solve it with the bring radicals and so on. No. Come on. Stop fooling yourself. there is no there is no quintic formula, okay? Just repeat after me, no quintic formula. Okay, anyways, so let's see if you can find a solution. But while looking for a solution, let me tell you a couple things that'll make your life easier. What is a? A is the fifth root of 5 plus x, right? Okay, great. And so if you want a to be an integer, a could be 1, possibly, right? Can it? Maybe, who knows? A could be 2, a could be 3. Test these out. Take a look. Like if a is equal to 2, right? If a is equal to 2, then that probably means that 5 plus x is 32. That means x is equal to 27. Do you think 27 is going to work? How could we test that? Easy. Go back to the original problem. Plug in 27. 27 plus 5 is 32. This is going to give you 2, obviously, because we know a is equal to 2. But then when you plug in 27, Houston, we have a problem. 4 minus 27 is negative 23, and the cube root of negative 23 is, I don't know that, right? You have to use a calculator. That's not good. So you're basically looking for a special value of x, which comes from a, that will make both of these good integers such that their sum is equal to 3. Okay, you don't really have to go to that extreme, because I'm about to show you something super magical, maybe super mathematical. Sorry, why do I say all these fancy words, right? Because I really want you to appreciate the beauty of this. Take a look at this equation. What is the first thing you need to check? Do you know? It's the sum of the coefficients. Yes. If you add these coefficients up, 1 minus 1, of course you have to consider the negatives, right? Plus 9 minus 27 plus 18. Let's add the positives. 1 plus 9 is 10. 10 plus 18 is 28. Great. So that is 28. And minus 28 is 0. Houston, we have a surprise for you. That means a is equal to 1. Remember, I've been telling you this all the time. Always check. And if that doesn't work, check the evens and odds. If they're equal, then negative 1 is a solution. And then go for the rational root theorem, something that divides 18, such as plus minus 2. And you see 2 doesn't work, but we already got a solution, so you don't have to worry about it. Are there any other solutions? You can check. Divide this polynomial by a minus 1, long division or otherwise, and then find the quartic, solve the quartic. No, just use Wolfram alpha. It's too much work. Again, be lazy. You're going to learn more, okay? Or you're going to get better results most of the time. Now, if we set this expression equal to 1, which is the value of a, right? From here, we basically get the following. Raise both sides to the 5th power. 5 plus x is equal to 1. Which means x is equal to negative 4. Wait a minute. Does that work with the other radical? Let's go ahead and check it out. We have the cube root of 4 minus x, right? But that's equal to b. If x is equal to negative 4, okay, you don't need to worry about this. Just plug in x here. 4 minus negative 4 is 8, and this is going to be the cube root of 8, which is equal to 2. So here's what we have. Let's go ahead and rewrite the original problem. Cube root of 5 plus x. Plus the 5th root the 5th root of 5 plus x, plus the cube root of 4 minus x. Now, we know that x is equal to negative 4. If x is negative 4, you're going to get 1 from here, and you're going to get a 2 here, and 1 plus 2 is equal to 3, which means x equals negative 4 is a solution. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath and aplusbi, and bye-bye.